We got another episode of 99% Visible, DevOps Reliability. Today we're going to be hearing about achieving zero downtime from Cindy Sridharan. And yeah, I'm really excited. My name is Spoons. I'm the CTO at Lightstep, and I'll be moderating today. Let's see, a few other kind of details. So today's talk is part of 99% Visible, a series of tech talks about building and operating reliable systems. And before we get started, today's talk is going to be recorded. I'll share a link to the recording with everyone who signed up for the session. So thanks to you that are joining in later. Speaking of signing up, if you'd like to hear about future talks, please head over to 99percentdevops.com. We do this from time to time, usually about once a month or so, and we can keep you up to date about future talks. You can also see past talks that we've had as well, which is some pretty cool stuff there. If you're tweeting about today's talk, which I encourage everyone to do, we'd love it if you'd use the hashtag 99%visible. And yeah, so the plan for today. After I finish up my introduction, I'll hand things over to Cindy. And we've budgeted about 30 minutes for her talk, and then we'll save time for questions at the end of the talk. So I encourage everyone to use Zoom's Q&A feature. I think there's a button down here somewhere. Anyway, you can submit questions, and then we'll get to those at the end. Before we get started, I also just wanted to take a quick minute to thank our sponsors. 99% Visible is sponsored by Lightstep, Blameless, CodeFresh, Rollbar, and Noble9. We all know that DevOps is more than tools, but tools like these can be effective ways of kickstarting new DevOps practices within your organization. Automation is certainly a really important part of DevOps. And yeah, that kind of brings me to the topic of today's presentation. So with that, I want to introduce today's speaker. So Cindy's an infrastructure engineer, has been working in this space for some time. She's written about a bunch of different pieces of it. You can see some of her posts on Medium and on Twitter and other places like that. But yeah, I'm just excited to see what she has to share today about deployments. And again, we'll have some time at the end to answer questions, so please use the Q&A feature. And with that, I want to hand it over to Cindy.
Good morning. And let me start sharing my screen. Can everyone see the presentation? Yes, no. Okay, there we are. So good morning, everyone, and thank you so much for being here. And today I'm going to talk about zero downtime deployments. My name is Cindy, and I have been an infrastructure engineer for the entirety of my career. So first, let's start with talking about what really we mean by zero downtime. So in my experience, in my the ways I've sort of implemented this, often tell me that when I mean zero downtime, I mean zero downtime for the end user. So when infrastructure is being upgraded, any part of the infrastructure is being upgraded, the fact that we do not want this update to affect any end user facing requests. So that is what I really mean by zero downtime here. That there's going to be no user facing downtime, which may or may not correspond to, there being no infrastructure downtime, there being no, like instances being down or whatever, but it just means that the end user is not going to be impacted by upgrades. So there are multiple ways to think about zero downtime deployments. There are multiple ways to think about it. And in this presentation, I want to talk about the sort of like the most important aspects of implementing this. And the first thing I'm going to talk about is how to implement or how to sort of like make sure that a single process, because whether you're running a single instance of something or like a million instances of something, ultimately you're sort of like dealing at the per process level. So at the beginning, we're going to talk about some of the strategies to implement zero downtime releases at a single process level. Then we're going to look at how this might be achieved across the entire infrastructure, because that is very different from like what really happens inside a single process. If time permits, we're going to look a little bit into how stateful systems, like, for instance, a database or a queue, or even something that's, holding like a very long-lived sessions, stateful sessions, can actually be deployed, or services that actually have these characteristics can be deployed without any downtime. And probably the most important part of this discussion is going to be on observability, what to measure, what really needs to be instrumented, and how to debug things when something goes wrong. So those are sort of like the key areas I want to focus on today. So let's start with what happens at the single process level. I call this infrastructure strategies, both this as well as what happens across the infrastructure, because it's sort of like the precursor to the next discussion. So what I mean by a single process strategy is, how do you sort of like make sure that a single process that's running, because whatever your infrastructure is, wherever you're running, whichever cloud you're running in, whatever your application is doing, ultimately we're gonna have like a Unix process that's running somewhere, right? So how do you basically tell a process to shut down? Because there really is no way, at least in POSIX, to basically have like RPC calls with like a single process to tell it to here's the way to shut down. You can kill a process, that's possible, but there's no way to sort of like tell it, well, start shutting down. There's no way to sort of like control a process management other than signals. So signals are ubiquitous. They're sort of used everywhere. They're available on all platforms, on pretty much in on every different types of systems that you're building. And what signals generally do, or the way this is implemented, is you install a signal handler inside your application. And what the signal handler will do is intercept a signal and then do something once a signal has been intercepted. So pretty much all platforms that I know of, whether it's cloud platforms or things like Kubernetes, all of these have support for signals. So the way individual processes are torn down is that you signal the process. Once the process is signaled, we expect the process to do something like stop accepting new requests, or basically in the worst case just completely shut down. And that is generally how you basically tell a single process to shut down. Now obviously it's not quite that simple, in that you just get a signal and you just shut down and you go away, right? Because when we're talking about zero downtime, what we want for that, which is that no end user facing requests should ever, or that no end user should ever see any sort of errors, or even any sort of like degradation in the quality of service when you're deploying. So that's kind of what I really mean by zero downtime deployments. So tying that back to signals, it's not simply a matter of saying, well, get a signal, just shut down and go away, because a single process might still be handling like many requests. In some cases it could be like tens of requests. In some cases it could be like even hundreds of requests, right? If you have like a very high performance server. And it's not just possible for the process to exit just completely aborting all of those requests, because that will sort of impact the end user. So what a lot of systems do is the way termination based on signal handling is implemented is, once a signal has been intercepted, the system will actually stop accepting new requests, and it will wait for some time for all existing outstanding requests to complete before it shuts down and exits. So that gives a way to this process to complete all existing requests. And while at the same time it stops accepting new requests. So it's not going to be taking new clients, but existing requests are not going to be impacted. And after a certain period of time, this is typically called like draining. So a service starts draining. That's typically what they mean. And there usually is something like a drain period that's configured. And once that period is over, the process will exit, irrespective of whether outstanding requests are completed or not. Now, based on the type of request that you're serving, if it's just like very short-lived HTTP requests, your grace period or your drain period is going to be in the order of maybe like a couple of minutes at worst, right? But if your single process is just running some large batch job, for instance, or, it's just running something that's, super time consuming, then in a lot of cases, the sort of like the draining period can even extend up to like a couple of hours. So there are pros and cons to this approach. The pros are that it's, like I said, it's ubiquitous, it's just POSIX, and it tends to work, fairly well-ish. The cons are that, again, it's POSIX, and POSIX signals have like, a pretty bad reputation for a good reason. And, they're just kind of like finicky sometimes to get right. Typical mistakes that I've seen people make when it comes to implementing signals is the fact that the signal handler sometimes ends up doing way too much. Now, it's important to note that any code that's in the signal handler typically needs to be something called signal safe. So and there are very, very, very few like standard system calls and even libc library calls that are actually system safe. So for a good example is, what I've seen a lot of people do inside the signal handler is, once you get a signal, you just log a statement saying that, hey, I received a signal, I'm going to start draining, right? That is something that you might publish to, your logging system, and you might actually even sometimes just sprint it if you're trying to debug what's going wrong with, your implementation. And the problem is that a lot of like logging libraries eventually end up calling like some function in the standard IO library. And basically any function that's defined in the stdio library is not signal safe. So what that means is that this could have pretty bizarre impacts on other parts of your code, for reasons I don't think I have time to go into right now. So if you want to look into the problems with signals, just look into like what signal safety means. And that should give you like a good idea of why all the code inside the signal handler needs to be signal safe. The other problem with signals is when you're trying to terminate an application that for some reason might have spawned a subprocess. There's a lot of software that, where we actually shell out to other tools to implement something, right? Maybe there's like, some existing tool that already does something really well, something like, an image processing tool or a video encoding tool or something, right? And basically, if you're just trying to shell out to that tool to do something else, and you're trying to shut down like the main process because you're trying to deploy the service, then signals can actually have a pretty sort of like strange effect in that case. So especially this becomes a problem when you're using a shell to spawn a subprocess, because shells don't typically relay signals from the parent to the child. So in this case, what ends up happening is that your parent process could end up dying after it gets a signal, but none of the subprocesses that spawned will ever sort of like really get the signal, which means that once the parent is exited, all of the child processes end up getting reparented to the init process. Effectively, they become zombies. Now, this again is not so much of a problem if you have, like an immutable infrastructure set up where, everything is running inside a container or something and the whole container gets torn down. So it doesn't matter if there are zombie processes. But if you don't have that, if your deployment model is still, somewhat, or your infrastructure model is still somewhat, mixed. You don't have this pure, amazing, like immutable infrastructure all over the place, then this could become a problem because you just end up with like, a ton of zombie processes. And if it turns out that these processes are actually doing some, compute intensive work, or, even some sort of like, they happen to be network bound or something, that can severely impact the amount of resources that is going to be available on that host, because there are all these processes that are just like hogging up all these resources. So if you are going to be implementing signals, just make sure that anything inside the signal handler is signal safe. And second, also make sure that if your process happens to be spawning sub-processes, that they actually that you actually kill all of them before you exit, because signals are not going to be conveyed to them. So that's with signals. One way to work around signals is to use what I call the privileged RPC calls method. So if, for instance, you're running an RPC server, a gRPC service, or even like an HTTP service, then effectively all that they're doing is sort of like, exposing RPC methods or exposing HTTP endpoints. So one thing that could potentially be done is you just have like a special endpoint to just shut down the service. And, to shut down, you don't have to like use signals, but you just probably want to make an HTTP request, an RPC request to this method or to this endpoint to basically tell it to start shutting down. So that sort of like gives you complete control over the process lifecycle, because now you're no longer reliant on signals and all of the sort of like the weird idiosyncrasies of signals. But the problem with the RPC call approach is, well, they have to be privileged in that you don't want anyone to just be hitting that endpoint. So you only want, your operator or your control plane or your automation to actually hit this endpoint, which means that you probably have to secure it, which then means that you need like a very strong security story for that, which is not, in my opinion, that's not particularly a bad con because your service is anyway going to need a good security story. So, but you just have to make sure that access to that RPC call or that endpoint is severely restricted. So, someone cannot just go and kill everything in your fleet by just issuing an RPC call. But the pros of this approach is that it gives you, like I said, complete control over how you want to shut down a service. And you don't have to deal with any of the weirdness of signals. And, it just becomes yet another call and yet another RPC call. And you can basically do any kind of bookkeeping that you want to do. Usually, when I'm in bookkeeping, usually this is true both for signals as well as for the privileged RPC calls. When I'm in bookkeeping, what I really mean is that most services shut down their listening socket. So they're not, I'm talking about network services here specifically. And to be very clear, this entire discussion is about like services. I'm not really talking about like, desktop software or like even mobile applications, because I don't have any experience in that area. But when you talk about like backend systems and backend services, most of these are sort of like network services. They listen to requests and they serve them. And shutting down the listening socket when you want to shut down is sort of like a pretty standard way of telling these to sort of like terminate, but still giving them enough time to sort of hang around and to complete what they're actually doing. So this means that the users are, less likely to see any disruption because requests that they sent are actually going to be completed, even if a service is being upgraded. This is what happens on a single process level, right? Because ultimately, like all deployments are like you kill a single process, you bring up a new one, right? Except in scenarios where you can sort of like do something like a hot reload, where you can sort of like reload like a new binary into an existing process. And like some systems do that, but these typically tend to be systems like, Nginx or something, or something that's like a proxy, and they have like a very specific sort of like deployment guidelines. So in general, most systems that people are writing, most applications serving business logic are not of the type where you basically just do like a hitless config update or something. It's more like you want whole new code to be brought up. The next thing I want to talk about is immutable versus mutable infrastructure. We talked a little bit about this when we talked about signals, in that, the whole zombie process problem is not that much of a problem if you have this complete, immutable infrastructure world. And for those who aren't familiar with these terms, what I mean by immutable infrastructure is that, you don't really go upgrade things on hosts. If you want something new, you basically bring up the entirety of the infrastructure. So this would be like a VM with, you bring up a virtual machine with all the processes that you need running inside it. Or, in the container world, this could also just be, you bring up a brand new container with everything that's running inside it, in that you don't sort of like update anything in place. Updating things in place, again, has its pros and cons. And that is what I call like more mutable infrastructure, which is, you go update things while they're actually running, rather than completely waiting to, tear it down and bring up like, another host or like another VM or something like completely new. And I think mutable infrastructure, the reason I'm talking about this is because it sort of comes into, it sort of becomes relevant when we start talking about proxies. And proxies are, so, by proxies, I mean like network proxies, something like, an Nginx or an Envoy or an HA proxy. This might be something you might be running, at the edge, or could even be something that you're running, as a sidecar. So the reason I talk about this is because in a lot of cases, it's not possible to just completely say that, you're just going to completely tear down one proxy and you're going to bring up another one on another host for various reasons. It's required that, you bring up a new version, you deploy the software onto the same host. So in that case, there's, the possibility of one of the existing proxies completely draining and shutting down, whereas something like load balance, something would cut traffic over to the new thing. That strategy doesn't work. So in these cases, what you're really going to have to do is somehow cut over traffic from like one process to another process on the same host while they're both alive, right? So the way that is done is, there are a couple of like primitives available in Linux and in macOS. Basically, some of these are POSIX compliant, some of these are not, where you can actually literally transfer all of the file descriptors from one process to the other. So that's kind of what some of these proxies do. So what Envoy does is what HA Proxy does. I'm not sure about Nginx, but I wouldn't be surprised if it does something similar, where instead of sort of closing the listening socket and waiting for like a new service to come up and start accepting requests, what we do is we just transfer all of the listening sockets from one process to the other new one that's brought up on the same host, using some of these mechanisms. Again, I don't think I have the time to go deep into how some of these things are implemented, but there's enough resources on the web to understand if anyone wants to dig deeper into these things. But the good news is that, again, very few of us are going to be implementing these, right? Most of us are going to use like some off-the-shelf proxy or some open source system, or even if you're running in AWS or something, your ALB is actually going to be implementing all of this itself. So you as in like individual developers or individual sort of like application development teams don't have to be implementing some of these things. But for the sake of completeness, I just added it here because it's kind of like important to talk about how to sort of upgrade things in place in the sort of mutable infrastructure scenario. So in the immutable infrastructure scenario, which is the other one, and this is sort of like, over the last decade, I think this has gained a lot of popularity, and it's come to the point where this is sort of like the de facto standard to really be deploying systems. We have three sort of like general ways of doing this. Well, it's typically two. Canary is like a special case, but I just added it here again for the sake of completeness. The first one is what I call blue-green deployments. The second one is called what I call rolling restarts. Again, a lot of platforms, a lot of like standard tooling, and a lot of open source systems have support for these things. And these are, again, like somewhat standardized. So, the way I've seen this happen, the way I've seen deployments happen at most organizations or in most teams is compliant to like one of these strategies. So in a blue-green deployment world, this is also called red-black deployments by some people. What you really do is you have, so now we've sort of like left the single process upgrade category to, and we're talking more about like how do you upgrade like a fleet of services? How do you do how do you upgrade something over, across your entire infrastructure? So what blue-green deployments let you do is you bring up, so let's say you have like 10 instances of a single service that's running, right? What you do is you bring up like 10 new instances of the service. So the currently running system, the system that's, the fleet that's serving production traffic is called like the blue deployment, and the new one is called the green. So basically what you do is you just bring up like a completely new deployment, and you basically cut traffic over from blue to green. So there are pros and cons to this approach. That is like, a very simplified way of how blue-green deployments are done, but I think it captures the essence. Again, like I said, there are pros and cons to this approach. The pros are that if something goes wrong, it's easy to cut traffic back because you just have to update your load balancer, or you just have to update DNS or something, right? So it's fairly simple. The cons are that it comes down to infrastructure cost, right? If you really have like a very large fleet, if you have like 1 million hosts running, then it just becomes problematic to sort of like have two of them running, right? Because it's not just one, but it's like 2n. So if you have like two, if in the case of 10 processes, you probably need 20 processes in the blue-green world, so that we sort of switch traffic over, then still keep the old ones alive to make sure that in case something goes wrong, we can cut traffic back. So the cons is that it's just more expensive. Which sort of brings me to the second approach, which is one of rolling restarts. So the way rolling restarts is typically implemented is you, instead of just completely cutting over all of the traffic at once, which is a pretty bad idea in any case, what you really do is you gradually ramp up traffic from like the old deployment to the new one. So if you have like 10 processes running in the current production infrastructure, you bring up maybe 2 new deployments or 2 new instances of the new code, and you cut traffic over just to 2 of them. So you have like 8 of the old one and 2 of the new ones. So you have like 80-20 split, right? And if the new deployments look good, then you start gradually rolling over more. So from 80-20 we go from like 60-40 to 40-60 to the point where 100% of the 100% of the new code is running. 100% of the new code is actually servicing 100% of the new traffic. So again, there are pros and cons to this approach. The pros are that it's not going to ramp up infrastructure costs. It's a pretty tried and tested way of doing things, and it also sort of like gives you the ability to gradually sort of like see how things are going, right? Because with the blue-green deployment, we're completely cutting our traffic from like 100% of the old one to 100% of the new one. If for some reason there's a problem with your new deployment, then like 100% of your users are going to be saying downtime. Whereas with the rolling restart, you can make sure that only 20% of the people will be impacted initially, and then you can roll back anyway. So that's basically a way to reduce the user impact in case something is wrong with deployment. And what some people do is also kind of like a mix of both these strategies, in that you have like a blue-green and a rolling deploy strategy that's sort of like combined together. So the way that works is you have like say 10 of the old processes, and then you bring up 2 of the new one, but you still do like the 80-20 split. But you still have 2 of the old processes around. So now you have like 12 of the processes, that's like about 120% of your capacity, but it's not too bad because it's not 200%, right? And then, you start doing more of a rolling strategy, in that you kind of like start upgrading, cutting traffic over more and more. So the good thing is that in the worst case there, you're just going to have like about 120%. You're just going to be running 20% over capacity, and that's acceptable to a lot of people. So these are like the 2 general ways in which you upgrade you upgrade code across your entire infrastructure. And again, there are a lot of like, the more complicated your sort of deployment model is, or the more complicated your infrastructure is, the more complicated even something like a simple rolling restart gets, right? If you're just trying to do like a kernel upgrade on like 1 million hosts, for instance, then even if you're doing some kind of like a rolling restart there, it's possible that, upgrading all of them, especially, across multiple data centers and like potentially even like multiple AZs, is going to take a while. So it's not something as simple as, well, you just cut it new, like 5 minutes and it's done. In many cases, it takes hours, sometimes even days to like completely upgrade like the entire fleet. It comes down to like what it is that you're upgrading, but I've seen this be, like deployment strategies go from, whether you're doing blue, green, or rolling, go from like being fairly simple to make super nuanced and complicated, even if like the fundamentals are still the same. Finally, I want to talk about canaries. So this is not really it's not quite the same as blue, green, or rolling, but the way canaries work is you have like a production fleet, and then you bring up like a couple of canaries to which you send traffic. And then, to have the canaries, to evaluate the canaries, you have some baseline metrics, and you end up comparing them. You compare how your production systems are doing versus like how a canary system is doing. And if the metrics look good, you sort of promote the canary to be like a production host. Now you can still apply things like sort of like the rolling strategy. I wouldn't even call it rolling restart. It's more like the rolling strategy to like the canary approach, where if you bring up like a small number of canaries, it's correct. Then you just roll that over to be like a production system, and then you sort of like start with the rolling upgrade for like the entire fleet. But the good thing about the canaries is that you don't have to wait until code is deployed to production to see if it's correct or not. You actually send production traffic to something that is that ensures that your impact, if something goes wrong, is going to be very low, because you're actually comparing actual real metrics. Any questions so far?
Nothing's come up yet.
Okay, cool. So I don't know how I'm doing on time, but I'm actually going to, I could probably be here all day talking about stateful systems, because there's just like so many different like strategies and types of these systems. So what I'm going to do right now is I'm going to skip this section, I'm going to go talk about observability because I think that is what most people are here for. And I think that is also pretty important. And, if time permits, I'll come back to stateful systems, or, if anyone has any questions, feel free to send them to me. And, I'll probably try to do like a much longer write-up about this topic, because I think it's pretty expansive and it's fairly important. And I don't think like 10 or 20 minutes is going to help me get through it. So let's finally talk about observability, which is that, okay, what do you measure when you're sort of like deploying code, right? What are some of like the deployment centric things that you have to be measuring, or what are some of the deployment specific things that you have to be looking out for when you're implementing like any of these strategies, right? So the first thing I would say is look at the availability. Hopefully everyone is measuring that. It's just a metric of, just like how available your service is. Usually it's implemented in the form of end-to-end checks. So, from a user's perspective, you sort of like get to know whether the service is available or not. And, one of the ways to verify that your zero downtime strategy is actually working is by basically looking at availability metrics, right? To see what it looks like when you're actually deploying code. If it's at 100% or close to 100%, or 4 nines or 5 nines or whatever it is that you're hitting, then that means that your deployment is disruption free. But in the case that it is not, if you start seeing steep drops in availability at the same time that you're deploying code, then that means that something's wrong with your strategy, and you'd have to probably go and dig into like why that is happening. The other really high level metric to look at, just to verify that this thing even works, is end-to-end latency. So this is important because again, in the proper zero downtime, if in the infrastructure is set up so that every service is draining correctly, everything just works as expected, then your end-to-end latency of requests a service is is servicing at the time of deployments should not vary much from the end-to-end latency of requests that that service is processing in normal times. And to go a little bit deeper into this, I want to talk about very specific metrics to look at, right? Because these are just like very high level metrics that tell you, like availability metrics, like that's end-to-end error rates and end-to-end latency is just like a very high level metrics that tell you, well, is it even working or not? But how do you sort of debug it if for some reason your availability is dropping, but you don't really understand why? So that brings us into like a little more fine-grained metrics. As well as a couple of other ways we can sort of like understand what's really happening with our deployments. So typically there's this notion of the red metrics some people talk about, which is request. It starts for RED, which is like request rate, error rate, and duration of requests. So these are some of the sort of like very high level metrics that pretty much any service should be reporting and people should be looking at. In a lot of cases, a lot of SLOs are driven off of these metrics. And this is all good, but especially when you're looking at deployment metrics, it's important to look at red metrics, but it's also more important to look at very specific sort of like metrics even under these, right? So total request rate is good, but it becomes very important to look at your request completion rate, also your rate of retries, because request completion rate is just how many requests are completed, how many requests that you receive are sort of completed during the deployment window. And this is important because it really tells you if it sort of informs how you need to tweak your drain period, right? Because if services are going to be draining before they completely exit. And we also observe that, the request completion rate is actually fairly low. If I get like 10 requests and at the time of draining, I'm only really able to complete like 7, it means that 3 of the requests are still failing, which means that, like users are potentially going to be impacted by that. So it's important to look at both request rate as well as like request completion rates. And these two things are different. And I think it's especially important to keep an eye on both of these metrics when we're sort of like looking at, verifying if the deployment strategy is fully correct and, we're able to deploy code without any end user facing downtime. The other important metric, or a sort of like that falls under the request rate umbrella that is important to look at, is the rate of retries. So in a lot of infrastructures, you have, if you get a failed response from a service for whatever reason, you have, clients could either retry, or you have like intermediate proxies that retry, or sometimes even you have like, if you have like a microservices architecture or something, you have like one service that's failing requests, you have like its immediate downstream that actually retries, right? And retries are in general a pretty good strategy to sort of like mask transient errors. But especially when it comes to deployments, it's important to look at the rate of retries of the immediate downstream, which is like the immediate service that is actually sending requests to the service that we're trying to deploy. And it's important to look at just how many requests are actually pure, like new requests versus how many requests are actually retries. And this is important because in an ideal world, if during the whole deployment window, first of all, the rate of retries should not be particularly high because, if your upstream is continuing sending traffic to the service that is actually trying to drain and, it's rejecting requests, then that is going to be counterproductive because, you actually want the downstream to send requests to a service that's actually can accept new requests, right? You basically wanted to send requests to the new service, not the old one. And in a lot of cases, people tend to retry, but they don't tend to like look at what are the sort of like error rates and what are the metrics for like the rate of retries, what is like the success rate of retries and where exactly we're retrying. So I think that is very important to measure because we want to make sure that we're not retrying to services that are actually draining. And this typically works fairly well-ish because when system is draining or when system is trying to shut down, it also sort of updates the service discovery mechanism. And most of like the routing logic happens, based on what service discovery is telling and health checks in some cases. So, in some cases, it's possible that a service is sort of draining, but it's still passing health checks because typically it's still up and running. So, the downstream thinks, yeah, it's okay. It's possible to retry because the service is still healthy, or, at least it's up. But then, but it's actually draining, which means that it probably only upgraded like service discovery or something. So it's important, again, I don't want to generalize here because like a lot of different infrastructures implement this differently, but just look at your rate of retries because you don't want that to be, exceedingly high, because that just means that, something's down, and which is again why like we're retrying so much, right? So in a typical sort of like in a good scenario where, your deployment strategy is pretty sound, the rate of retries during deployment should be more or less the same as, during standard mode of operation. The other thing we have to look at is the error rate at a given, service. So if I am talking to another service and, that service is sort of like shutting down, then what I'm going to, it's going to reject a lot of the new requests coming in, right? Because that's kind of what we wanted to do. But we also want to make sure that we don't continue routing requests to this old one. So again, at the immediate downstream, it's important to look at error rates, but specific, not just like general error rates, because in my experience, when people set SLOs or SLIs, and this is it's perfectly valid for a number of reasons, but people tend to look at like the aggregate error rate, which is like an error rate across like all the requests that you're trying to serve. Whereas in some cases, what you have to specifically look for is specific types of errors, things like connection refused. That's when, you cannot establish a new connection, or like if you have like custom errors that you're returning when, a service can no longer accept requests, you will have to go and set an SLO specifically on that metric, which is not just the general error rate, but error rate for like, specific types of errors. Again, if you see like an increase in this error rate when you are sort of like in the middle of a deployment, that potentially signals that something is wrong. And yet your strategy is not, fully sound. Maybe a service is not draining correctly, maybe like this red-blue deployment thing is not fully cutting traffic over to the new one, or maybe it's cut traffic over, but the new one is unhealthy for some reason. It cannot service traffic. So look at error rates, but look at like specific errors. And ideally you want to like maybe set SLOs on this very specific errors that you're looking at, just to make sure that the strategy is pretty sound. The other way, another approach you can do is, because I've mostly been talking about metrics right now, but another potential thing you could do is, if you're using something like distributed tracing, make sure that you requests that are retries are separately tagged compared to just normal requests. Because then when you look at, when you're trying to go analyze like, why certain error rates are high, or what the retry rate is, you can actually go and filter based on those attributes. But if you don't really make that distinction, then it becomes really hard to sort of like analyze a single service to see, well, is it just like retries that are failing? Is it just normal requests that are failing? Why is something retrying so much? So a lot of that gets pretty complicated and also pretty difficult to debug if you don't have, if you're not specifically watching out for these specific metrics and making sure that, like all the spans are tagged correctly and everything, so you can actually go discover things. Finally, it's also important to look at the duration of requests, because in general, when I say duration of requests, I mean duration of requests, especially, in the deployment window, because that's kind of what we're focusing on here, not throughout like the whole, operation of the service, but specifically during deployments to make sure that this is correct. You want to look at like just how long it takes for general request to succeed. And this again should be more or less the same as how long it takes during like, the normal times, normal periods of operation. Because in some cases, if the end-to-end duration of request is too high, it could possibly imply that something is just retrying way too much because some service is not draining and still accepting traffic for some reason, or it could mean a number of things. But this is sort of like a good bellwether to understand like what's in general happening. So these are like some of the general metrics that we want to be looking at to just verify at a high level that everything is kosher and everything is just working as expected. Again, this is a big generalization, depending on the type of service you're running, depending on, like just what its request patterns are, what its traffic patterns are, what the response times are in general, how it sort of like, what are some of the downstream systems it talks to. Based on all of this, there are like a number of scenarios where, the metric that you're looking for are, some variation of these top level metrics, right? You're not, maybe in some cases, you're not really looking at the type of retries, but you're looking at, specifically the number of like duplicate requests, right? Because in some cases, instead of sort of like retrying, what they do is some systems hedge requests. They send two requests at the same time, and whichever comes back first, they respond back to that. So you, depending on like how you sort of route requests and how you're load balancing, you probably want to make sure like you're looking at the right metrics. But these are like some examples that I can think of that are very sort of like deployment specific, in that yes, in general, you have to be looking at these metrics, but when you're looking at them from like trying to debug a deployment, then you have to look at very specific metrics, or like very specific tags in these metrics to be able to understand what's going wrong. So I think that is it. Again, like I said, I sort of like completely skipped this section because it's too long. But in general, again, when it comes to the metrics, I still think even when you're deploying like a stateful system, yes, there are like potentially tons of other new metrics that you have to be looking at, things like, replication traffic, replication duration. If you're talking about like a system that uses replication, right? Something like, a database that has like maybe like 3 instances, and you're making sure that, all of the data is like, replicated across, all 3 instances, then you have to look at like a ton of additional metrics. But in general, the essence of the philosophy is kind of like the same as what you do for like, pretty much every other service, because fundamentally it's not very different, right? You're just bringing down a single process, bringing up a new one, cutting traffic over, and making sure that everything is looking good. So yeah, I think that is all I have today.
Awesome. That was
Sorry.
great, Cindy. Thanks. Yeah, that's great. We do have, about 10 minutes where we can take some questions. A couple came in. So yeah, I think you're not going to get away without talking about stateful systems. So maybe if you could just there's a couple minutes, and maybe just, I don't know, maybe like at a high level, like strategy, best practice, if you could touch on like how that might play out in a blue-green deployment, or if that even makes any sense to you, that would be, I think that would be cool.
So a blue-green deployment strategy for like a stateful system? Is that what you mean?
Yeah, that was one of the questions that came up, but maybe
Okay.
just kind of set a little context for us, and yeah, talk about best practices.
So, I mean, again, the reason stateful systems becomes a little hard to generalize is because there's just so many of them, and they're just like so different, right? It's very different to talk about, well, how do you sort of like deploy something like MySQL in a blue-green fashion versus something like Cassandra in a blue-green fashion, because again, like because MySQL, you're basically just bringing up a single instance, right? Whereas in Cassandra, you're potentially bringing up like you need like more than one. You're effectively going to have like a ring of systems. Again, it depends so much on like what are your quorum strategies, what is your sort of like sharding strategy, and like a whole bunch of other things. So if there's like, if they can get a little more specific, then I can probably try to answer here. But it's just, in general, it's just very hard to generalize. I know that sounds very hand wavy, and I'm sorry about that, but it's just, but in general, like if you're trying like a blue-green strategy, it's very important. So the first thing I would say is when it comes to stateful systems, just again, this is again like more of an observability opinion, but make sure that you can actually distinguish between different traffic types, because I think that is like one of the most important things. Just normal traffic versus like, things like health check traffic or like, gossip traffic internally that's happening within like all the different nodes versus like replication traffic versus like, how to, like in a lot of cases, like you shard systems, right? Basically, you just say like, okay, all these requests that come to like this one shard will go here, and like, or even like, so it's in general, it's just pretty hard to generalize. That's again why and that's again, sorry, sounds very handy, but
it depends, right?
it depends. It depends is like the big answer. But in general, if you want to, just do a blue-green deployment strategy, again, it comes down to really, okay, you're bringing up the new one. But I think most of the challenge with stateful systems is how do you, once you start cutting over traffic, you have to have, most of the challenge lies in how do you sort of like, which nodes to talk to, right? Because ultimately that's the problem, because once you cut over traffic, you have to somehow replicate all of the state that exists on the old node to the new one. So it's important that before you start cutting over traffic, that replication has happened, which is like an internal sort of like bookkeeping traffic. Once you've completely replicated state in the new machine, and where, but there are also some systems that actually don't need that. They can basically auto bootstrap, right? They can basically bring up new ones, but they don't actually serve traffic because they're still waiting for like all of the replication to happen. Or in some cases, you can bring up new ones and they still keep old ones around, so that they can sort of, this is a good example of Cassandra, where the coordinator will actually make sure that it's sending the right request to the right vnodes, which actually have the data, right? So again, it's very hard to generalize because it very much depends on what type of system you're trying to deploy. But
yeah.
Just a high level overview would be, make sure that the data has been replicated or the data has been recreated at the new system, if that's needed, before you sort of like do the cutover. So
yeah, that makes sense. And I think your thought about segmenting the traffic is also pretty important, because just remembering, especially if this is not software that you wrote, that there's a lot of other things that are happening underneath the hood, but are still network traffic. Maybe we'll let, if folks have other questions about stateful systems, go ahead and post them. But maybe pause on that for a minute. I wanted to ask, like you talked about how like a lot of folks are shifting more towards a mutable infrastructure. Is there still a good case that you've seen for using kind of an older school style of deployment where you're actually changing the infrastructure itself?
I would say it really depends on a number of factors. Again, in general, when it comes to just like stateless systems, I don't think that is still, at least I can't think of a very convincing reason why people shouldn't move to complete new like immutable infrastructure model. But there are again cases where it makes sense in some cases to actually not just bring up something completely new. One good example is if you're like a CDN network, or if you are a somehow like running like an edge proxy, right? So what that means is there's like really nothing in front of you that knows how to shift traffic and do all of these things that's needed to sort of like make sure that your draining processes aren't getting any traffic and all of that, right? This is like the first bastion. This is like right at the front of things. There's nothing in front of it telling it to move. So in that case, you either you probably like hard-coded IP somewhere, at least for like the very front end nodes, because once you get through that, then what it gets into your infrastructure and you can do whatever you want. But if you're like the very, very edge of the infrastructure, then in some cases it's, especially when you're talking to CDNs or something, some people just hard code configs, right? Because it doesn't change that much. Or even if it does, it's, maybe it's just something, maybe you're just like using a DNS-based load balancing system. And for some reason, it takes DNS for a while to upgrade. And you don't want there to be any downtime when that is happening. Maybe this is acceptable inside the infrastructure when you can retry and do a lot of other fancy things, but it's probably not acceptable at the client level. So in those cases, it may make sense for us to have like more of a mutable infrastructure model where it's just not possible to completely like bring up something new and think, at least you have to keep deploying to the same host for whatever reason,
Right.
right? So in that case, you will have to basically make sure that the new thing comes up on the same host. And yeah.
Yeah. Okay. Cool. That makes sense. Yeah. It's it's fun to think all this old school, to me, old school like Unix stuff still matters so much.
It actually does. Surprisingly, it does a lot more than people give credit for. So
Yeah,
yeah.
yeah. I guess I was going to ask if you're taking a more like a more modern approach, I guess, and you're doing more kind of a mutable style. Do you still have to? I mean, should you go out and buy a bunch of books on POSIX and things like that, or can you get away
I mean, it
with
really
ignorance?
depends, right?
Yeah.
Like I said, again, like the very de facto standard of sort of like telling systems to shut down, because ultimately, whether immutable infrastructure, mutable or whatever, we're just dealing with POSIX processes, right? That's ultimately what's coming up. Even if you're dealing with containers or VMs or whatever, you just have to bring up a process on a host, right? And we tell it to shut down. So that's not changing, no matter what else changes. So at some levels, yes, but maybe not, you don't have to go very deep into like understanding like how fiddling with descriptors and stuff. But, basically like talking about sockets is very, that's standard, that's POSIX, and that's not going away anywhere. Unless like, we discover how to like, just like a feature to sockets and we just know how to do it. But that's not happening anytime soon. So
Yeah.
POSIX is here and potentially here to stay. So
Yeah.
yeah.
Yeah. Cool. One of the you mentioned at some point like distinguishing like health check traffic and things. Could
Mhm.
you maybe say a few words about best practices around health checks and readiness checks
Oh,
and
oh my
how that
God,
kind
so
of fits
much.
in?
There's so much to say. Health checks could be like a whole separate talk in its own right. But again, I think in general, I think it's important to note, especially in the deployment sort of context, it's very important to distinguish between a process health check versus like what I call service health checks. A process health check is more like, is this process up? Because if the process is not up, something like the process manager will restart a new one, right? Or like some other thing is going to go because something is going to be health checking this thing, is going to go kill it and start a new thing. And it's important that, especially when services are draining, even once they go into the drain mode, that they don't start failing health checks, at least like the very low level process level health checks. Because what if in case your draining period is like 2 hours, right? You're running on some really large batch jobs, you just don't want them to shut down right in the middle, and you have a very long sort of like period when it's draining, and you want the process to be up for all that time. You don't want it to serve new traffic, but you still want to be up. So whether it's so in that case health checks becomes complicated, because yes, it has to pass process level health checks, because otherwise it's going to be toned down. But it shouldn't be passing what I call service level health checks, because that is the basis on which like a lot of like other downstreams decide whether to route traffic to the service or not. So in that case, effectively we have like two different health checks now that need to be in place, right? And so that's one thing that I've seen. A lot of people tend to conflate the two. And Kubernetes, for instance, has this idea of readiness and liveness checks, right? One is like
Right.
just saying if this thing is up or not. One is saying, well, if it's ready to drain traffic. But in the other scenario, we don't, in some cases, we can probably repurpose the same for even when you're trying to shut down, which is like, is the service, is the process even up? Versus like, can it still take traffic? But a lot of other systems, they just have like one general notion of a health check, right? If it pauses, you route traffic. If it doesn't pause, you don't route traffic. And that gets complicated in deployment scenarios, because you still want to process up, but you don't want to get any traffic. So, and
Right.
potentially it can be in that state for a very long time. So,
Right. And also when you're warming up as well, right? You might want to be in
right.
that state. So
Yeah, and there's like a lot of warm-ups, especially if anyone who's deploying any Java application needs to probably warm up the JVM, right? So it's
right.
like you just don't want to start getting traffic immediately. And same thing with like, well, shutdowns are, you can basically, once a process is done, you can just completely kill it. But again, the fact that it needs to be around for a while is something that's important.
Yeah. Cool. Yeah. Maybe another talk all about.
Maybe. Yeah, health checks are like super, super nuanced. And yeah, in general, the way most people talk about it is like, yeah, it's health checks passing, health checks failing. It's nuanced in so many ways because it has just so many implications across the sort of like, so many implications for so many things. It's like implications for just like how much traffic how much intra-service traffic there is, right? Because a lot of cases there's just like a ton of health check spam. It comes down to like, well, how do you sort of route traffic? Just because the service is healthy doesn't mean that it can actually take more traffic. Maybe it's overloaded. In that case, health checks will start failing. But just because health checks are failing doesn't mean the process should be killed. And it's very, very nuanced. And yeah.
Yeah. Cool. Well, we're just about out of time. So I wanted
And I
to.
probably covered like maybe 20% of what I had in mind for this topic, but
It's great. No, I thought it was really Really great, and the overview kind of, and just sort of seeing the different pieces of it and how you think about it. To me, I guess, I mean, I have a lot of other questions, but I think that's a great state to be in. So
Yeah, and just if anyone wants to talk to me, like just email me. It's just first name, last name at Gmail, or maybe like tweet at me or something, and happy to answer more questions. And I might even try to like write down all these thoughts that I have, so that there's like someplace more permanent than because I definitely enjoy speaking more. Sorry, I enjoy writing more than giving talks, which as most people might have observed today, I was super rusty because I haven't done this in a very long time. So maybe I'll just try to get down all my thoughts on like all these topics, including stateful systems, which is probably like, yeah, super. So it's so expansive that it's probably going to take me like at least a month to find enough time to write down everything I know about it. But maybe I'll do it for Christmas. Who knows? So
yeah, cool.
let's see. Cool.
Yeah, there's one question that just came in. Maybe you can just tweet some like good reads on the topic would be cool for people
Oh
as
yeah,
well.
sure. I can do that.
Okay. Awesome. Well, thanks again for a great talk. For everyone that's been watching, this has been 99% Visible DevOps Reliability, a series of talks about building and operating reliable software systems. If you have other thoughts, you can find both Cindy and me on Twitter. If you signed up for today's talk, you'll get an email about how to register for subsequent talks. Like I said, we do this every month or so, and we're kind of just figuring out what the next one's going to be. And I just wanted to say 99% Visible has been brought to you by Lightstep, Blameless, CodeFresh, Rollbar, and Noble9. Thanks again, Cindy. Thanks, everybody, for joining, and we'll talk to you soon.